let us discuss about the phase. The phase of a wave defines the motion of the wave at a particular distance and at a particular time. Equation of a simple harmonic or a periodic wave is yx comma t is equal to r sine of 2 pi by lambda into vt minus x. So this function is called as the argument of sine, and this argument of sine is called as phase. So here phase is equal to phi, that is 2 pi by lambda into vt minus x. If the initial phase difference is equal to phi 0 or epoch is equal to phi 0, in that case phi is equal to 2 pi by lambda into vt minus plus phi 0, where phi 0 is the initial phase difference or the epoch. Phi is equal to 2 pi by lambda into vt minus x. If phi 0, initial phase difference, is equal to 0, this phase changes with respect to the time and with respect to the distance. What is the rate of change of phase with respect to the time, keeping the displacement constant? So we can say that d phi divided by dt is equal to 2 pi by lambda into differentiation of vt is equal to v, as the velocity is constant, and differentiation of x as x is equal to constant is equal to 0. We can also show that differentiation of phase with respect to the displacement is equal to 2 pi by lambda, differentiation of vt is equal to 0, and differentiation of minus x will be equal to minus 1. So d phi by dx is equal to minus 2 pi by lambda. The minus sign shows the phase lag. Let us see what is the relation between the particle velocity and the wave velocity in a simple harmonic wave. Let a wave travel in a medium with a velocity v. This velocity v is constant, but the velocity of the particle at its position changes because the particle describes simple harmonic motion about its mean position. So the velocity of the particle changes, but the velocity of the wave is constant in a medium. We know that the equation of yx comma t is equal to r sine of 2 pi by lambda into vt minus x plus phi. Here phi 0 is equal, the initial phase is equal to 0. Now the differentiation of dy with respect to t gives us the particle velocity. So u x comma t is equal to dy divided by dt. Here r is constant. The differentiation of sine is cos 2 pi by lambda into vt minus x. Now the internal differentiation is 2 pi divided by lambda into v, as differentiation of x with respect to t is equal to 0 here. Now we show that it is equal to 2 pi by lambda into v into r cos of 2 pi by lambda into vt minus x. Now let us differentiate the displacement y with respect to the x. So dy divided by dx comes out to be r. Differentiation of sine is cos, so cos 2 pi by lambda into vt minus x. The internal differentiation comes out to be 2 pi by lambda, and differentiation of minus x is equal to minus 1. Let this be equation number 1. Let this be equation number 2. Here from first and second we can clearly see that 2 pi by lambda or cos of 2 pi by lambda into vt minus x is equal to dy by dx. So we can show that dy by dt is equal to minus times v in dy by dx. This is the particle velocity. So u x comma t is equal to minus v d by dt of y x comma t, where u is the particle velocity and y is the displacement. Velocity of a particle is equal to product of the velocity of the wave and negative of slope of the wave curve at any position and time. Talking of the particle acceleration is the time rate of change of particle velocity. We know that particle acceleration is x comma t equal to d by dt of u x comma t. Previously we saw that u is equal to r cos of 2 pi by lambda into vt minus x into 2 pi by lambda into v. Now r is constant, 2 pi by lambda into v is constant, so it comes out, so r 2 pi by lambda into v. Here differentiation of cos is equal to minus of sine 2 pi by lambda into vt minus x, and internal differentiation of 2 pi by lambda into vt minus x is equal to 2 pi by lambda into v. Now it comes out to be r 2 pi by lambda into 2 pi by lambda is 2 pi by lambda whole square into v square, minus comes out, and sine of 2 pi by lambda into vt minus x. Now this r and sine of 2 pi by lambda into vt minus x is equal to y. So the acceleration ax comma t is equal 2 pi by lambda. That means this is 2 pi by lambda into v whole square, and this r sine of 2 pi by lambda into vt minus x is equal to minus y. Here is the minus sign. Now we know that lambda by v is equal to t. That means 2 pi by t whole square minus y. 2 pi by t is omega. That means acceleration is equal to minus omega square y. So the acceleration of the particle is minus omega square y, where y is its displacement. Now as the velocity of the particle changes, the acceleration of the particle changes. Now also we can see that velocity of the wave is constant. Velocity of the wave is constant, therefore acceleration of the wave is equal to 0. Here we are talking about the acceleration of the particle whose velocity changes, that is equal to minus omega square y, where omega is the angular frequency and y is the displacement of the particle. Thank you.